Alright guys, welcome back. We're going to start the first section. And this first section, as you can see, is entitled An Overview of Statistics. So a lot of the first chapter, guys, are going to be going over some terminology that we're going to use throughout the course. And that's what we're going to see in this first section. Okay, so I know many of you, probably all of you, have heard of statistics. Okay, that term is used a lot, so we're going to take a closer look to see what it actually is. We're also going to learn some key concepts, okay, that'll be used throughout this course as well. Now, fortunately, in this first chapter, there's not really going to be any calculations that we're going to be doing. In this course, guys, most of the calculations or most of the math is really just going to be arithmetic. Okay. But anyway, let's look at these learning objectives. So we're going to look at the definition of statistics. We're going to distinguish between what's called a population and also a sample. Okay. So you've probably heard both of those terms. I would be willing to bet you have some intuition about what a sample is, but a population may be different. As well as between what's called a parameter and then a statistic. Okay, so here we encounter that word again. And then furthermore, we're going to look at how to distinguish between descriptive versus inferential statistics. Okay. All right, so I've got a graphic here. So this is just an example article in which we actually see some statistics. Okay, so let's look at it. It says, what Americans know about science. So my guess would be that somebody conducted a poll, sampled a few individuals, and asked them some of these questions. Okay. So for example, do you know that the Earth's core is the hottest layer, okay, as opposed to the mantle or the crust? So apparently 86% actually knew that the Earth's core was the hottest layer. And 86% here, guys, this is a statistic, okay? And then furthermore, 74% of individuals that were asked this question knew that Jonas Salk developed the polio vaccine. And then furthermore, 63% knew how to interpret a scatter plot. We'll actually talk more about scatter plots in this course. And then 34% knew that water boils at lower temperatures at higher altitudes. Okay, so for example, if you live in Denver, water's actually going to boil at a lower temperature because there's less pressure. Or if you were on top of Mount Everest, okay, if you could actually survive up there. But anyway, these percentages here, these are what we refer to as statistics. Okay, and then you can see the source is this research organization. All right, so let's look at some definitions. The first one is data. So I know you guys have heard of this. So data consists of information coming from observations, counts, measurements, or responses. Okay. So the data in this previous example would be that roughly 86 people out of every 100 knew that the Earth's core was actually its hottest layer. Okay, but data can be many different things, guys. Data could be an individual's body temperature. It could be a score on an exam. Okay, observations, counts, measurements, or responses. So data could be the response to a yes or no question, or an individual's favorite presidential candidate. Okay, that's all data. And there's different types of data that we'll look at here in a little bit. And the statistics is actually the science of what we do with this data. Okay, so it's the science of how we collect it, how we go about collecting it, how we go about organizing it, analyzing it, and interpreting the data, okay, in order to make decisions. So statistics is really the science of collecting this information and then basically creating a story from it, or letting it create a narrative that helps us make better decisions. In fact, I had a professor in college that said statistics, is really just the science of being able to make the best decision in the light of uncertainty. Okay. All right. So 2 types of data sets that we're going to talk about. The first one is a population and a sample. Okay, so what's the difference between these two? Well, a population, guys, is going to be a collection of all outcomes, responses, measurements, or counts, okay, that are of interest. Okay, so I'll give you an example. When they do presidential polling, they're trying to get an idea of how the population feels about a specific presidential candidate. Well, unfortunately, we cannot poll every single individual that's going to vote in the upcoming election, okay, whenever that may be. So what we typically do is we take a sample of the population. So the population is this larger set that contains all the data that we would be interested in knowing. But many times it's impossible to collect the data from this population, okay? And so what we do is we end up taking a sample, and a sample is a subset or it's part of the population. Okay, so instead of polling every single registered voter, we pick out a handful, maybe 1,000 of them, and then we ask them, okay, how they feel about a certain presidential candidate. That's just an example, but a sample is always going to be smaller than the population, okay? And the reason we use a sample, guys, is because in most cases it would be impossible, or nearly impossible, to collect data from a population, okay? All right. Let's see. Much of what we do with statistics is to qualify the results of an experiment performed on a sample, okay? So we've already established that, it's going to be difficult for us to collect data from a population. So then we look to a subset of the population, a sample. And we collect that data and then we do some stuff with it, okay? So that's really what statistics is about. And then what we can say about the entire population based on our experiment, okay? And then with what confidence? Okay, so when you hear, some presidential poll, they'll say that, X candidate, 47% or 53% of the electorate is favoring a specific candidate. Okay, that's just a statistic from a sample. Okay, but that gives us an idea of how maybe the population feels about this particular candidate. All right, so let's look at an example here. It says in a survey, we've got 834 employees in the U.S. And they were asked whether they thought their jobs were highly stressful. So of the 834 respondents, 517 said yes. Okay, so what is the population and what is the sample? Well, the population would be all employees in the U.S., okay? So if you look right here, this rectangle, this represents the population, all employees. But it would be impossible to poll all employees and ask them how satisfied they were with their job. So we pick out 834. And the 834, the data from those employees, that constitutes our sample, okay? So responses of employees in the survey, that's our sample here. And then outside of this subset, we have the responses of all the other employees. Well, we don't know what they are. But if we did, together that would make up the population, okay? All right. So let's look at some examples now. So it says, determine whether the data set is that of a population or of a sample. So it says the blood pressure of each patient in a hospital when they were admitted. All right, so the key here, guys, is this word, each. Anytime you see the word each or every or all, like in this previous example, all right here, that indicates that we're talking about a population, okay? So the population in this example is the blood pressure of all the patients that are in this hospital, okay? So the blood pressure, that's the data, okay? All of those different blood pressure readings from all of those patients, that would be our sample. And those actual blood pressure readings, that is the data here, okay? So it's a measurement. But in any case, this represents data from a population, okay? And then number 2, the number of parasites on 25 catfish caught in a lake. Okay, so maybe you're trying to figure out the health of some of the fish in a lake. So you can't evaluate every single fish that's in the lake. So you look at 25 catfish. Okay, so evidently we're talking about just catfish here. But the 25 catfish, or the number of parasites on these 25 catfish, that data would pertain to a sample. Okay, the 25 catfish is a subset of the population. The population would be the number of parasites on all of the catfish that are in this lake. All right. And then number 3, it says the final scores of each football game played on a Friday night. So again, guys, we see this key word right here, okay? So the data in this case are actually the final scores. And it says of each football game. It could have said every football game. So that indicates that this is going to be data from a population, okay? So we're not talking about just 10 of the football games that were played on this Friday night. We're talking about all of the football games, okay? The final scores from all of those games. So that data would be from a population, okay? All right. Yeah, I think maybe I've got enough time to get through these. I've got a 15-minute limit at the moment, okay? So let's look at this example. It says identify the population, the sample, and data for the following situation. Okay, so number 4, the Department of Energy conducts weekly surveys of 800 gas stations in the U.S. to determine the average price per gallon. On May 11th, the average price was $3.10 per gallon. So that's actually about what it is right now, at the time of this recording. All right, so the population, guys, it would be the price per gallon of all gas stations in the U.S., okay? Actually, I may just be able to finish this one. Price per gallon from all gas stations. Okay, and then we're going to say in the U.S. because that's what we're considering here. All right, and then the sample would be the price per gallon from these 800 gas stations that were sampled, okay? So price per gallon from the 800 gas stations. Okay, so typically what's probably done is you pick a few gas stations from every state. And then the data would be the actual prices per gallon. Okay, the prices per gallon. Okay, that's going to be your data. So you're going to get a lot of different prices per gallon. They're probably all going to be somewhere within this ballpark, 3.10. You know, on the West Coast, gas prices are typically higher. Arkansas actually has some of the lowest gas prices, so there would be some variation. But anyway, the statistic though here is the $3.10. That's the average from these these 800 gas stations that were actually sampled. Okay, and I think I'm going to stop here. So we'll pick up in part 2.